Welcome to this explainer. Okay, today we're going to decode some massive, foundational microeconomic concepts using a scenario almost all of us have agonized over at some point: finding a decent place to live near campus. Honestly, if you've ever struggled to lock down an apartment, you've actually participated in a complex economic model without even realizing it.
We've got a lot of ground to cover. We'll start with basic apartment market modeling, look at demand, supply, and equilibrium, and then see what happens when the market changes. After that, we'll explore alternatives like monopolies and rent control, and finally wrap up with Pareto efficiency and the long-term outlook. Let's dive right in. First up, apartment market modeling. Let's set the stage here. In economics, models are basically just simplified versions of reality. We're stripping away all the messy, unnecessary details so we can focus purely on the core essentials.
Picture a mid-sized university town. We've got two main options for housing. The inner ring apartments are right next to campus, highly preferred obviously. Then there's the outer ring. These are basically the fallback option. They require a pretty miserable bus or bike commute, especially when it's raining or snowing. Now, naturally, everyone just wants to roll out of bed and walk 5 minutes to class, right? This creates intense competition for a very limited resource. The real question we're answering today is, who actually gets these prime apartments, and exactly how much is it going to cost them?
To figure that out, we rely on the principle of economic optimization. We have to assume students are going to perfectly optimize their choices, meaning every student is going to look at their budget and choose the absolute best living situation they can realistically secure. Nobody wants to pay more than they absolutely have to, but everyone wants the best possible spot.
Moving on to demand, supply, and equilibrium. Now we get to explore the invisible economic forces that actually decide who gets handed the keys to those coveted inner ring apartments.
First, we need to talk about your reservation price. Think of this as your personal financial line in the sand, literally the absolute maximum amount of money you are willing and able to pay. Say one student can scrape together a max of 500 euros for an inner ring apartment, but another can only afford 490. Well, if the rent is set at 494 euros, only the first student is packing their bags. It's a hard limit.
So if we were to line up every single student in town by their reservation price, starting from 500 euros and going down, we actually create a perfectly descending market demand curve. It makes total sense, right? As the price drops, more and more students are willing and able to rent. Higher prices, lower demand. It's a completely undeniable relationship.
But wait, we have to look at the flip side, the landlords. In the short term, you can't just magically conjure up new apartment buildings overnight. It takes time. So whether the rent is 200 euros or a whopping 1,000 euros, the physical number of inner ring apartments is completely fixed. On a graph, that short-term supply curve is just a straight, unbending vertical line.
Let's put those together. If the rent starts way too low, let's say 200 euros, student demand is going to vastly exceed that fixed supply. And what happens next? Competition. Students will inevitably try to outbid each other, which drives the price up and up until it hits what we call P-star. That's the perfectly balanced equilibrium point where the exact number of students willing to pay perfectly matches the exact number of available apartments. At this sweet spot, nobody has any incentive to change what they're doing.
All right, part 3, market equilibrium changes. Now that we've established our perfect equilibrium, it's time to inject some real-world chaos into the model.
This is my favorite part to explore. What actually happens to that perfect market equilibrium when the foundational situation suddenly changes? How does that perfectly balanced price adapt when we shock the system?
Let's look at a couple of scenarios to see how market shocks force prices to adapt. In scenario A, imagine a brand new building miraculously opens up, increasing the overall apartment supply. That's going to push the equilibrium price down because, well, there's less scarcity. But scenario B is super fascinating. What if a landlord decides to sell 10 of their rental apartments to condo buyers? The rental supply instantly drops by 10. But here's the kicker. The rental demand also drops by 10 because the students who bought those condos are no longer looking for rentals. Both curves shift simultaneously. It really is an elegant dance of economic forces.
Next up, alternatives, monopoly, and control. We're going to pivot away from a perfectly competitive market and look at completely different ways to allocate these exact same apartments by fundamentally changing the rules of the game.
We're going to test 3 distinct alternative systems, what economists like to call alternative economic institutions. We want to see exactly how they change who gets to live near the university and at what cost.
First, imagine all inner ring apartments are scooped up by one giant entity. A discriminatory monopolist acts kind of like a ruthless auctioneer. They figure out your absolute maximum reservation price and charge you exactly that amount, extracting every single cent of value from you. Every apartment gets filled, sure, but your wallet is completely empty. Now, an ordinary monopolist, on the other hand, is forced to charge everyone the exact same price. To maximize their total revenue, they might actually set the price so high that several apartments purposely sit empty. They're literally artificially restricting the supply just to boost their bottom line.
Let's look at our third alternative, government rent control. This is where local authorities step in and basically say, nope, the equilibrium rent is just too high for students. So they mandate a strict price ceiling, a PMAX, capping the rent way below what the competitive market naturally dictates.
Now, what is the mathematical result of this? Because the price is artificially capped, eager students are going to vastly outnumber the physical apartments available. You get a massive excess in demand. And since price can no longer be the deciding factor of who gets an apartment, the whole market kind of turns into a lottery. Securing a place suddenly depends on who you know, under-the-table deals, or who can spend the most waking hours frantically refreshing message boards. Finally, Section 5, Pareto efficiency and the long term. Let's figure out how economists actually judge which of all these different allocation methods is the best. I mean, how do we even measure success here?
Well, economists use a very specific baseline called Pareto efficiency. If a system is Pareto efficient, it means it is completely impossible to improve one person's situation without simultaneously worsening someone else's. Basically, there is absolutely zero wasted opportunity. You've hit a point where any tweak to help one student would actively harm another student or a landlord.
When we evaluate our 4 systems against this baseline, the results are pretty eye-opening. The competitive market? Pareto efficient. Apartments go exactly to the students who value them the most. Surprisingly, the discriminatory monopoly is also Pareto efficient. Every apartment gets rented, so there's no wasted space, even though the landlord is hoarding all the financial benefit. However, ordinary monopolies are inefficient because apartments sit empty while students desperately want them. And rent control? Also inefficient. Why? Because an apathetic student might secure a prime inner ring unit through sheer luck, while a desperate student who values it way more is stuck taking the bus.
To conclude our analysis, I want to leave you with a provocative thought to ponder. Everything we just talked about assumed a fixed number of apartments in the short term. But if we fast forward to the long term, where developers can finally construct brand new apartment buildings to chase profits, the supply curve is going to shift. Which of these economic institutions will actually sustain Pareto efficiency then? Will rent control stifle that new construction? Will monopolies build more or less? It's a huge question that pushes this model right out of the textbook and into the real long-term world. Thanks for joining me on this explainer, and keep questioning the economics around you.